Hello everyone, this is going to be a little bit of a different thing. We're just going to do a little dive into powering up a ship's boiler. So this here is not exactly like a one-to-one scale accurate simulation. There's a lot of things that are simplified. For example, various valves are just, sort of open close kind of thing, whereas in real life you'd be able to, when you click on that, you would open up a PLC control window and you'd be able to see the is value, the set point, and the effective parameter, which in this case will be flow. So little things like that, but as sort of a start to complex systems, I think it's a great place to start. So before we even touch the boiler, we're going to need to run through some basic sort of some basic systems that the thing relies on. For example, we can't start a boiler without power, so we need to get some form of power going from our emergency systems first. So without that, let's just jump right in. So let's go to the EL system, electrical system here. We have the emergency switchboard. We're going to close everything except for the spares. And you may be wondering, if there's no power yet, why are we closing all of these circuit breakers? And the answer is quite easy, really. If you start up your generator and you're going without like any power fed to these systems, when you close these circuit breakers, the generator is going to have to throttle as you're closing these, and you're definitely going to put in a lot of strain. It's much easier just to shut the bus tie to the emergency generator to power these systems from a black start condition. This is what the emergency generator was designed to do. This is not always the same with every system. You certainly couldn't do that with a turbine generator without, a lot of preparation, hours and hours of preparations. Black starts are incredibly difficult things, but this is a ship. We've got diesel generators on here, and diesel generators are designed specifically for the black start in mind. So this is a perfectly okay thing to do. Let's start sending power. I notice I haven't done this panel yet because that consumes our batteries while I'm talking. So let's go ahead and close all of this. And we've got our light relay 3 going, showing we've got full power to the system. We can go back to the emergency generator here, and I'm going to go ahead and freeze the simulation to talk about this. So here our emergency generator is as we can see, diesel oil generator. We have the diesel oil generator makeup valve. Opening this valve will fill the emergency generator diesel oil service tank. This tank comes with a two sludge tank valve, a tank drain valve, and this is because if you're having the oil sit for a while, what you'll get is you'll actually oil, and this is crazy, oil has a lot of water content in it. It's kind of crazy because oil's hydrophobic, but it's true. It's like animal fat. When you're rendering down animal fat, you're releasing all of that water too. It's the same thing. So as this oil sits here, the water that's in it, because oil is hydrophobic, the water that's in it, that fat is going to rise and the water is going to fall to the bottom of the tank. So if your oil has been sitting here for a while, you'll need to drain the sludge. out of the tank, which is the water mixed with a little bit of oil. You want to drain all of that down so you just have the pure diesel oil in here. There are a series of duplex filters is what they're called. This is automatic in here. Like I said, it's not a one-to-one simulation, but a duplex filter is just two inline filters, and they're used a lot on oil, fuel, and hydraulic systems, and in food processing plants as well. You want that continuous operation. So when you're using one filter, if that filter gets, messy, it's ready to be changed, you just simply switch to the other filter. And in the cases of food safety, you can very quickly, just clean off that filter. The clean filter just, it's probably been sitting there for a while, a little clean, and then switch it over, and you're good to go. Then you can do the full filter change on the other side of the duplex filter. There is a bypass here on that system. It's a little bit complicated, or excuse me, not a bypass. This feeds back, so this is backflow, right? Well, it is a bypass going to the day tank. If the day tank is full, you'll bypass back to the service tank, so the system will continuously be circulating. We have a lift pump to form the suction required to pull the diesel oil out of the servicing tank and put it into the day tank. That's its whole job. The day tank is going to be where we pull from to power the generator. And that we can see its levels currently 80%. We have a booster pump here that boosts the pressure. So we have a higher fuel pressure in here. It can get injected really nicely. Same system of duplex filters, but then we have a sort of PLC here. This system here is able to regulate the speed of the generator. That matters in AC systems. As you know, well, you probably don't know, but the speed of the generator is what makes the frequency, not what makes the power output, right? So when you're synchronized, the power output's generated by Faraday's law or Lenz's law. When you go and you push more fuel in there, you're wanting the thing to spin faster, right? And that would raise your frequency, and you wouldn't really have much of an effect here on the wattage output. You'd just be increasing the frequency. But when you have the excitation voltage, which puts your counteracting magnetic field on this generator to keep you at that fixed 1818 RPM, that extra force, like when you try to push two magnets together, that force is what induces the power current itself, your amp output available to you. So we get the speed controller to regulate the frequency, and then we can control how much it is burning and how much exhaust gas we're pushing over the turbocharger blades. So very basic. Fuel is boosted in here. We get an ignition. The exhaust gas will first of all go through a filter here that's square with an X, which we can assume, just because it's an exhaust system, we can assume it to be a catalytic converter to take out some of the nasty gases. And then it's pushed over the high pressure turbine segment and then fed back through the low pressure turbine segment. And that spinning turbine has the generator output that gives us our frequency and our power. The low pressure gas powers a spinning blower to keep the system cold, push air through there, you know, so you don't overheat, and it's pushed back in and thus feeds the cycle. Basic stuff. Here we have our cooling system. To assist in getting the generator going, we have the hydraulic accumulator system. We can start on just hydraulic, or we could start off of the start battery. So our cooling system to help keep everything cold through liquid in conjunction with the blower. We'll have our, of course, our cooling water makeup valve, which will inject water into the system. Level is 90%, so that's what we want. We have a fan and radiator system here, much like a car, except instead of water, it'll be, you know, some sort of coolant diluted with a little bit of water, of course. We have our cooling water pump, which flows through, and the dual nature of this is the lube oil gets cold as it flows through the system. But the cooling effect will also preheat the water. Not a lot, right? We want to be cooling, but we don't want to send some thermal shock. We don't want to uneconomize the burning in this generator. So if we just preheat the water a little bit, we can use that preheated water to cool off the combustion engine here and then send it back out for chilling. We have a temperature control here, so as needed, we can bypass the radiator and fan system. Variable, of course. And then we have the two bilge. The bilge tank, basically a place where you send all your wastewater. And then lastly, we've got our lube oil makeup. We can open this to fill the level. 70% is perfectly fine though. And then we've got our lube oil pump here. We pump lubrication through the system. A little bypass here as needed. And the same thing, we're dealing with an oil system, so we've got a 2-sludge tank valve. It's really, really easy. You can see I've pumped up the hydraulic accumulator to help get this going. But we're going to use the start battery. The start battery feeds in through here, we can see. So we've got our batteries outputting to the emergency generator here. And then we've also got the battery charger. So you see we won't be charging the battery until we get some power. That goes without saying. Why would a battery work for this type of task though? So this is actually kind of cool. A generator, it is just in a reverse motor. So those fans on your computer that are spinning, those are motors, the fan motors. Those are also generators. If you spin those fans manually with your finger, you're actually generating an electrical current, and something that you can actually measure with a multimeter, provided you have the electromagnetic fan blades and not the mechanical ones. Mechanical ones, you will still get some output, but the EMs are better, more coils, more readable. And this can be applied to anything. Like, this is how regenerative braking works on an electric vehicle. When you've got your ability for your battery to push current through those motors to push the car by inducing a opposing magnetic field. And if you sustain that current and then you let the car slow down, the motion induces another opposing electric field to the direction that the motor wants to go. And that force, again, like pushing two magnets together, it's really hard, that type of force, the moving of those magnetic field lines through the coils generate electricity, and this is how regenerative braking works on an electric vehicle. So we're able to, like an electric vehicle, push in voltage to get this thing spinning. Once it spins and it gets the first combustion, we don't need the battery anymore, right? Everything, we just need it to get spinning so that the timing belt and everything gets going. We get the spark plugs going all up in the right sequence. Then after that, battery will cut off and she'll be started making power. So let's go ahead and do the check for that. The lube oil line needs to be greater than 50%, but not completely full, so that's good. We've got around 24 volts in the start battery, a little bit less, but that's perfectly okay. Radiator levels should be greater than 80, but less than 100. And now we will start the generator. So let's go ahead and do that. Start simulation. And now under engine control, let's go ahead and start. We can see we immediately get some alarms going. And we've got ourselves power. And that start battery is immediately charging. And here she is self-sufficient. She's got her own cooling. And we've finished a startup, turbocharger's online, and we're making power. We can see our bypass from the output of this lift pump to the day tank. It senses that the day tank is full, so it's going to, route the fluid back to the service tank. It's really cool that we got to see that there. We can see this valve has moved as well. And let's go ahead and check what that alarm was for. Yep, as suspected, main battery voltage. So let's go ahead and let's get that main battery charging. So we'll go ahead to the emergency switchboard and let's get that transformer connected. Can't do that yet. That's right. Why can't we do that? Because we have no synchronizing. So let's go to the electrical power plant. We've got ourselves the emergency generator and the emergency bus bar. Let's go ahead and set that voltage controller on. The voltage controller, that's our excitation voltage. That's what's going to get us synchronized to allow us to synchronize to the bus. We've got governor controls, but once our voltage is stabilized here, we're in black start condition, so we can just go ahead and close that breaker. And there she goes. She's on the bus. Everything is getting stabilized, and we can go ahead to the emergency bus bar. We've got our power coming back in. We can close our emergency transformer, and the whole thing comes to life. So that's sort of the start of everything. The next time we'll get up the not the emergency generator here, but we'll get up the diesel generators here. We'll get DG1 on the buses, and we'll prep DG2 for start and leave it in standby. So that's what we'll do next time. We'll take a look at all of the dependencies for that, which include our seawater system over here. So that's just sort of a little teaser, if you will, to some of our processes. I hope that didn't look too confusing, but absolutely, some of these panels for the first time, they can be very, very, very overwhelming. Like, I'm sure when you saw the emergency generator, you're like, oh my god. And it does get a little bit worse. Here's a diesel generator one. You can see this is a significantly more complex system that we're dealing with here. So we'll take it at baby steps at a time. And I'll see you then.